Hey guys, we are here for the next lesson, and we are going to moving into circles. Now, everything we've done is going to stay with us. You'll see how some of it comes into play in a few minutes. But let's jump into circles, go over some basic vocabulary and components, some of which you're already familiar with, but we'll probably build on that a little bit. All right, so let's do this. So let's see. We're going to start with circles. We'll start with some basic vocabulary. So a circle is the collection of points that are equidistant from a given point that we call the center. So if we think about that pretty simply, we have a point that we're going to call the center. And now we want to identify all the points that are the same distance from that point. So for example, let's just say roughly 2 inches. We're going to make a point. Now I want to find all the points that are also 2 inches apart from that center. And if I start to identify all those points, and this is obviously a freehand drawing, but as I fill in more and more points, instead of dots, we start to get this very solid curve going around it all the way around. And we know that a circle is 360 degrees all the way around. Now, this big curve is actually the circle. We've got the interior space, and we've got the exterior. But the circle itself is just that big red curve that goes all the way around, or 360 degrees. Okay. Next, we want to talk about a radius. So a radius is I'm sorry, before we talk about radius, let's talk about naming the circle. We always name a circle using the word circle or the little icon of a circle. Make sure that if you do the icon, you put a dot in the middle, because otherwise it's going to look like OA and nobody's going to know what you're talking about. Next, we talk about a radius. A radius is a segment that connects the center to a point on the circle. So in our example over here on the right, the radius measures 2 inches. So it's a segment going from the center to a point on the circle. In this picture below here, we've got a radius called AB, we've got a radius called AC, and we've got a radius called AD. And all radii of the circle are congruent. So we can see all three segments are congruent to each other. Since each point on the circle is the same distance from the center, that should make some sense. So again, moving forward in some vocabulary here. We have a chord. A chord, by definition, is a segment whose endpoints lie on the circle. So if we look at our example here, we've got 3 chords. We've got CD as a chord, CB is a chord, and EF is a chord. So a chord always lives inside the circle, endpoints on the circle. So we have 3 chords in this figure. Now, when we talk about a diameter, there's only one diameter drawn for us in this picture, and it is CB. So the diameter is a chord, but it's a special chord. It passes through the center of the circle. It's the longest chord of the circle. It's made up of 2 radii. So AB is a radius and AC is a radius. So the diameter is made up of 2 radii. So diameter equals 2R. Next, we've got things called tangents. A tangent is a line that lives outside the circle, but touches the circle in exactly one spot. So if we look at our picture here, AB is a tangent. It touches the circle at exactly one spot right there, called the point of tangency. One of the important properties about a tangent is that it is perpendicular to the radius at the point of tangency. So if we find the radius, and remember radius is part of a diameter, it is perpendicular to that radius at the point of tangency. So we have a right angle. Now, keep in mind, if we have right angles, chances are we're going to have right triangles, which means we're going to have to use some Pythagorean theorem and some trigonometry. So that's all going to come into play pretty quickly. One of the other things about a tangent is that we could have multiple tangents. And if the tangents come from the same point to the same circle, they are congruent. Now, they're only congruent up to the point of tangency. We don't really know what happens after the point of tangency. So we can't worry about what happens after that point of tangency. So tangent from A to B and the tangent from A to C are congruent to each other. We've got things like common tangents. Common just means that it's tangent to more than one circle. And then we can describe them as internal or external. So from one circle to another, they're going to be congruent, meaning, sorry about that. We have common internal tangents from the point of tangency to the other point of tangency. And the same thing on the other one. Those two are going to be congruent. If we look at the external, just internal means that they cross each other or intersect between the circles. External means that they don't. They stay on the outside of the space. But again, from where we touch one circle to the other, so that purple tangent and this red tangent are congruent to each other. So common tangent, they can come from an external point to the same circle, or they can actually be from connecting two different circles. And they're congruent. Next vocab word we have is a secant. So a secant is simply a line that cuts through a circle. So notice that the inside is going to be a chord. So we're going to have a chord on the inside. Once it breaks outside the circle, it's called a secant. So AB is a secant. AD is a secant. BC is a secant. DC is a chord. So again, some things to keep in mind there. Next, we have an arc. And an arc is a part of the circle. Remember, the entire circle is 360 degrees. So an arc is going to be less than 360 degrees. An arc goes from one point on the circle and it follows the curve to another point. So here in red, we just traced out arc AB. Now, it has a measurement, and that measurement is going to be in degrees. Measurement is not the same as length. It can be a long arc, it can be a short arc. That depends on how big the circle is. But the number of degrees just tells us how far around the circle. So 360 is all the way around the circle. But if it's a tennis ball, it's going to be a short distance. If it's the earth, it's going to be a long distance. So measurement is not the same as length. Measurement is not the same as length. Measurement is going to be in degrees. Length is going to be in distance, like inches, miles, kilometers. And we're going to get a lot more into arcs soon. Right now, we just want to understand what an arc is. Start at this point, follow the curve, get to the other point. We're going to get more in depth with that very soon. So let's do this. Pause the video, answer these questions, and then after you do that, hit play, come right back. All right, so we're back and we're asked to name a few questions. So let's see what we have going on here. We're asked to name radii. So radius goes from the center to a point on the circle. So we've got a couple in this picture. We've got AB, we've got AC, and we've got AD. We're asked to name the chords in this picture. So remember, a chord is a segment whose endpoints are on the circle. So we have chord BD, and we've got chord CD. Now we've got another chord here from C, but we don't know the name of this point, so we can't really use it in this question. Diameters. Well, we see one diameter in this figure, and it is BD. Notice diameter was included because it is a chord, but it's a special kind of chord. Next, we're asked to name the circle. And the circle is always named by its center point. So we've got circle A. So circle, put a little dot in the middle there, A. Remember to have that little dot in the middle so it doesn't look like OA. We're asked to name a secant. A secant includes a chord, but then breaks outside the circle. So given our figure, we can see that we have secant CG. So CG. We're asked to name a tangent. So a tangent lives outside the circle, touches the circle at exactly one spot. So our tangent is going to be out here, and we can call it like something like EF. In number 7, we're asked to find a right angle. Well, nothing in the picture is marked, but a right angle is always going to be where the tangent meets the radius, because remember, at the point of tangency, we will have a right angle. So we want to find that tangent and where it touches the radius. So we might have something like angle ADE. Now we could say ADF, we could say BDE or BDF, but we have to identify those angles. And then we're asked to name an arc that is less than halfway around the circle. So something like D to C, that's less than halfway. So we can name it DC, and we put a little arc above it. We could use something like arc BC. And again, we'll put a little arc above it. DB would be halfway, so that's not going to be a good answer for this question. All right. All right, guys, work on the homework tonight, and in the next lesson or two, we're going to pick up more work with those tangents and the fact that they're supposed to be perpendicular, and we will move forward from there. All right, see you all soon.